Welcome back. We are at the end of Unit 2. We're on Lesson 6. We've completed Unit 2, and now we are finishing up. I want us to know that we have gotten so much done in this unit, and it all comes down to Lesson 6. So let's go ahead and jump right on into it. It says that we are solving for a solution set when the equation has two variables. I can solve equations for two variables. I can also understand what discrete and continuous graphs represent. We are looking at standards A, RAI 10, and CED 2. So let's go ahead and jump into this. Now let's look at this equation. Y plus 4 equals 9. What's the only possible value of y that can make this statement true? Obviously it's 5. Okay, but what if I told you that in some instances I could possibly have more? Let's look at that. What if we had y plus z equals 9? What are some possible solutions for y plus z that would make this true? Now, what I want us to do is look to see what possible y values and what possible z values. Now you're probably saying, Ms. Killen, what is that little mark that you did to the z? 2's are so closely made to our z. Sometimes in math, you will see z's made with a little mark there to show that it's not a 2, it's a z. So I wanted to go ahead and introduce you to that because the higher the math is, more symbols that you will see. I don't want you to be confused about them, okay? So let's go ahead and back to this. What are possible values of y and z that I can add to get to 9? 4 and 5. 6 and 3. So let's go ahead and make a table of these. So I'm going to write my table up here. You write your table on your paper and let's see what we got. So I've got for my y values and my z values, obviously 0 plus 9, 1 plus 8, 2 plus 7, 3 plus 6, 4 plus 5, 5 plus 4, 6 plus 3, 7 plus 2, 8 plus 1, and 9 plus 0. Now you may be saying, Ms. Killen, you rewrote some answers, but did I? Now, up until this point right here, everything was going great and wonderful. But then you're probably saying, Ms. Killen, why did you rewrite them? Okay, my y values were 0 through 4, and then my z values were 5 through 9. But then I also needed to make sure that I could say my y values could also be 5. My y value could also be 9. So that's why I had them at this point, they reversed. Because my z could be 0. My z could be 3, depending on what my y is. So I want us to know that sometimes when we have these equations, we can have them where one variable in one instance can equal a number, and then in another instance, it could be the same number. All right, so let's look. What about the negative numbers? Do you think I could have put some negative numbers in for y and z and equaled 9? Sure, because we've learned multiple ways to have these. I could have maybe negative 2 plus 11, or, negative 1 plus 10. So there's multiple ways that I could have shown this if I wanted to make sure that I took in consideration my negative numbers. Good job. All right, but you need to understand, possible solutions can be listed in ordered pairs. X value and y value. They are your x values and your y values. And we remembered when we learned how to graph, I go over on my x values and then I go up or I go down on my y values. Remember, you have to crawl before you can walk. You always do your x's before you do your y's. Just think, when you do your alphabet, x comes before y. So you do your x values and then you do your y values. All right, let's see. Let's graph our ordered pairs. So on your paper, make sure that you have some graph paper or just draw you a graph and the ordered pairs that we came up with. Let's go ahead and write these. Now, on my new table, I put 10 and negative 1. So let's go ahead and do this. I have 0, 9, which would be about right there. Then I have 1 and 8, which is going to be about right there. 2 and 7, 3 and 6, 4 and 5, 5 and 4, 6 and 3, 7 and 2, 8 and 1, 9 and 0, 10 and negative 1. So what do we see about that? Do we see any type of patterns? Remember, I've always said that our math has to do with multiple patterns. It's always about the patterns. So do I see a pattern here? Possibly, possibly. Now, what do you notice about the patterns you graphed? Obviously, it's a what? It's a straight line. It's a linear graph. Linear. What does this word look like? As I write it up here, write it on your paper. What does that word linear look like? Exactly right. It has the word line in it. So it looks like a line. Could our ordered pairs have negative numbers? Absolutely, because we had 10, negative 1. So a lot of our graphs, we're going to have to look at those negative numbers. We're going to have to think about, can it be negative? Can I use negatives? How can I manipulate the negatives and the positives to give me my answer? All right, let's do some practice. Tashelle has 12 songs downloaded on her phone. The playlist features Taylor Swift and Alicia Keys. Create an equation using two variables to represent this scenario. List at least 7 solutions to this equation that you created. All right, so let's go ahead and write down what we think this could possibly be. So I know that I've got Taylor Swift plus Alicia Keys equals what? 12 songs. So how can I have my S and my K? What could I have for those values? Well, let's go ahead and make a table. Tables are our friends. Let's make a table to show what our possible answers could be. I'm going to write them up here. You write them on your paper. So I'm going to make a table of S for Swift and K for Keys. Obviously, 1 and 11, 2 and 10, 3 and 9, 4 and 8, 5 and 7, 6 and 6, 7 and 5, 8 and 4, 9 and 3, 10 and 2, 11 and 1. Miss Killen, it said just give 7. I know it said just give 7, but I wanted you to see, like the one earlier in the lesson, that just because the S is this, it doesn't mean that later on that the K couldn't be. So here's my table. Now, I've shown at least 7 solutions. Do I see a pattern? Are there any patterns? All right, let's see. All right, what do you think? Does this equation have an infinite many solutions? What does infinite many solutions? What does infinite mean? There is a certain cartoon that talks about infinity. Yes. So when I talk about infinity, that means it goes forever and ever and ever. So if I talked about infinite many solutions, what does that mean? That my solutions or my answers are what? That goes on and on and on forever. So my question is, does this, the Taylor Swift and the Alicia Keys equation or the scenario, does it have an infinite many solution? No, it doesn't. Because 1, you can't have a negative song, and 2, you can't have a fraction of a song. You can't have 3/4 of the song, because once you get there and it really gets catchy, it stops. So I can't have negative numbers and I can't have fractions. I can only have those natural numbers. So what does it mean? It could go on for on, goes on. And can this possible scenario have an infinite many solutions? No, it can't. It cannot. No, you can't have fractions or negative answers. Now, remember when we're answering questions, we always want to put why. I said no, comma, because. For instance, you always want to make sure that you give the justification of your yes and no answers, because sometimes giving that justification, you're going to say, oh, wait, it can or it can't. So you always want to follow up that yes and no with a because. The because is your transitions word to why. All right? Depending on scenarios like ours, like I just said, solutions must be natural numbers. We talked about that. We can only have a whole song. You can't have part of a song. This would be considered a discrete function, meaning there's a beginning and an ending. There's limitations. Sometimes we get limitations about what our teachers will and will not let us do. There's a limit. There's a boundary. With this discrete function or this discrete graph, there's a boundary. Okay, did you notice when we graphed the pattern? Okay, when we graphed it, obviously it's going to look something like this. It's going to be a line segment. A line segment has a beginning and has an end. It starts somewhere and it stops somewhere. Whereas of a line, it goes on forever. All right, let's look at the graph again. And here it is. And we notice that it has to stop somewhere. Because again, we cannot have a negative song. You can't have that. It says, now, what do you notice about the graph, the ordered pairs? We said it was a line segment. And how many solution areas, how many solutions are there for this? Okay, one, we can only have so many that says a whole number of songs for Swift and a whole number of songs for Keys. So there's obviously a boundary. Okay, we said that we had 7, 8, 9, 10, and 11. And then, so I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 possible ordered pair. So again, those boundaries, those limitations. All right, let's do some more practice. The difference of two numbers is 5. Let's create an equation using two variables to represent the scenario. List at least, let's put my at least, 5 possible solutions in a table and create a visual graph for this. So you do this on your paper. I'm going to do this on my board, and let's see what we get. Here we go. I'm going to use M plus N. Oh, nope, there's a difference. We need to make sure that we do the difference. So M minus N equals 5. So then what I'm going to do next is make my table. I'm going to have my M values and my N values. And then let's see what we've got. All right, so I have 5 and 0. I have 6 and 1, 17 and 2, 19 and 14, 20 and 15. There's so many possibilities. Ms. Killen, I didn't get those exact. That's not a problem because there's so many possible answers. I could not have put all of them up here on this board. You could not have put all of them on your paper. So my question is, what would this look like if we graphed it? Let's see. I'm going to pull up my calculator, a Desmos, and I'm going to put in some of my possible answers. Now, this is when we're going to use a new skill for Desmos. We are going to put a table in Desmos. Now, there's lots of possible ways that you can use Desmos, but using a table to show how ordered pairs look is one of those really good skills. So, on the top of your Desmos, you see a plus sign. You see the table. I'm going to put the table. I have my X and my Y values. So I'm going to put my values that I put in my table. You put your values. So I had 5 and 0. Then I have 6 and 1. Then I had 17 and 12. I had 19 and 14. And I had 20 and 15. And just for the sake of argument, I'm going to put -1 and 6. All right, so let's look at this. What do I notice about this graph? All right. Whoops. I put this wrong, guys. I'm sorry. Let me go back and fix it. This should be 1 and -6. There we go. All right. So what do I notice about this graph? It looks like a what? It looks like a line. So when I see this, I can say that it is linear. So then when I have 1 and that -6, should it be 1 and -6? 1 minus a -6, that would be 7. Nope, it should be a 4. I'm glad one of y'all caught that because I did not. So there, it's more on our line. So when I have this 1 and -4, even though it's in the negative portion of our graph, it is still on that line that can be a possible answer to this equation. So this shows us that negatives can be a part of our solution sets. All right, let's go back. So we created our visual with our graph. We did our table. We showed all these different amounts that could possibly make this true. So here's the important, very important question. How many solutions are there? What does that mean? What does that word? What does that new symbol mean? Infinite. Infinite many solutions, because it goes on and on forever. As long as it's a subtraction problem and it's a true statement, I can put loads and loads of answers in there. So that's a new skill with our Desmos, and that's a new symbol that we've learned. All right, how many solutions are there for this equation? And we said infinitely many solutions. And did we see a pattern? Yes, we did. We saw a linear graph. That linear graph again, it is linear. Now, since it does not stop, we can say that this is a continuous function, which we're going to go more in depth into this discrete and continuous later on in the course. But just know that continuous function or continuous graph means it goes on, it continues. Notice the solutions are rational that form the line. There can be infinitely many solutions that we talked about that would make this equation true. You always want to make sure that you're putting numbers in there that makes the equation true. It has to be a true statement. All right, time for you to master. Dakota's iPad has a combined total of 24 songs and movies downloaded on it. Let X represent the songs, Y represent the movies. Of the following, which could present the number of songs and movies on Dakota's iPad? Select all that apply. Go ahead and you and your table partner, go ahead and work these. And when you get done, come back to me and let's see what we got. All right, so Dakota's got her iPad. Let's see what Dakota's got on there. So it says that she's got 24 songs. So whatever happens is going to equal 24. So it says X represents the songs and Y represents the movies. So we've annotated our passage. So what if I just added the songs and the movies? Oh, well look, there's one answer. What about number 1? Could I take my songs and subtract my movies and get 24? Nope, can't do that. What if I had my movies equaled negative songs plus 24? Well, here's a question. Is that a true statement? Possibly, it's a true statement, but can I have a negative song? I can't have a negative song. So where this is a true statement, I'm going to say it cannot be a true statement for the passage that we have. I can have 12 songs and 12 movies. I can have 8 songs and 16 movies. Can I take my movies and multiply them times my songs and equal 24? No, I can't do that. So my possible answers are 12 songs and movies, 8 songs and 16 movies, and my songs plus my movies will equal 24. So how we go through these, seeing, yes, this is a true statement, but is it a true statement about the scenario? Y equals negative x plus 24, that's true. But can I have a negative song? I can't do it. All right? Let's not forget, some equations will have infinitely many solutions, meaning it goes on and on and on and on forever. There's multiple ways that we can answer a problem. Depending on the scenario, some equations will not be able to have a negative solution, like our songs, like Taylor Swift and Alicia Keys, and different things. All right, and then our discrete and our continuous functions. Remember, the discrete was just part of a line, and that continuous function was the whole line. It never stopped. I'm so glad that you came here to learn with me here at MPB. We've got through Unit 2. We've got a lot more math to work, but I'm so glad that you're enjoying yourself, and I'm enjoying myself learning with you. So thank you for learning with me at MPB. I am Miss Killen. Have a great day.